Describing and exploring data. Now you're going to have to do some of this for the homework. I suggest you go into Excel, but if Excel confuses you, don't go into Excel. Do it by hand, take a picture of it, scan it, upload it with a PDF, because you designing a graph on Excel isn't as important as understanding the concept and being able to read it. So if designing it is the problem, that shouldn't be the problem. So we're going to develop and interpret a dot plot, stem and leaf display, talk about quartiles, deciles, and percentiles, coefficient of skewness, a scatter diagram, a contingency table. So what you'll have when we get to the test and when we get to more advanced homework, I'll give you a graphic and you'll have to make an assumption about the data. Oh, there is a trend here, or there's not a trend, or yes, it's a normal curve, something like that. Dot plot groups data in as little as possible to identify individual observations. Those individual observations are not lost. All I do is just I'm dotting everything so I can see how my data looks. To develop a dot plot, each observation is simply displayed as a dot along the horizontal number line. So here's my information on number of vehicles sold the last 24 months, and I want to put it in a dot plot to compare the two. I want to see if there's a trend with these two, that it's the beginning of the month or the end of the month or at the same time or whatever it is. And again, I can go into Excel and do this. If you, and this is Minitab, which we don't use Minitab, but if you see the dots up here, and they have this on the PowerPoint again that you can print out, you can kind of see where these dots are, and I can see where the data is concentrated, and that's what it tells me. It's where is the data concentrated here. It seems to be more in the middle, so the middle of the 2-year span as compared to this one's a little more spread out, and there are definitely some at the end. Again, you're not going to be, that's not a big thing to know on the test. On chapter 2, we talk about frequency distributions, is how we organize data and that frequency, setting that up, the tables and putting all the frequencies in there, how it meant to the data that we have, how we set up those classes. An advantage of organizing the data is that we can get a quick visual picture. I can quickly look and see where the data is concentrated. Again, that's important for when we talk about these future chapters. There are 2 disadvantages to organizing data frequency distribution, that I don't know the identity of each value. So we talked about last time that there were, how we calculated the mean of a group data. And we used the example of the cars. It was like from 15,000 to 18,000, 18,000 or whatever. All I knew is that from, for example, 15,000, 18,000 in that group, if a car cost between those 2 amounts, that there were 10 of them. Well, I don't know if they were all 15,000, if they were all 17,000. I have no idea. So that's when they say the identity of each value is lost. That's what it means. I know how many people were in that group. I know how many people were in that age range, but I don't know how many exactly were 32 or how many cars were exactly $10,000. And then it's difficult to tell how the values within each class are distributed. Again, I don't know the individual values. One technique to be used to display this quantity of information is the stem and leaf. I will ask you to do this on the in-class test. The stem is just going to be the tens place, or the hundreds place and tens place, or whatever I'm dealing with, thousands place, whatever it happens to be. And the leaf part is going to be the ones place, showing the individual observations. So if you look at this, this is going to be 88, 89. A question I might ask you on either test would be to give you this and say, what's the biggest value, what's the smallest value? What would the smallest value in this be? 88, and what would the biggest value be? Yes, very good. Okay, I'll go, I'll get 15, and I don't know. And so that's good that you're adding these up. That's good. A step ahead. So here's the information. If I want to do a stem and leaf plot, again, I'm just lining this up, it's better to see. So 156, 150, and then 6, 155. You can also tell me how many observations, because I can count these. If I turn this to the side, imagine this to the side, if I draw a line over it, then I can see like this imaginary bell-shaped curve. And it looks like the data concentrates between the 90s and the 130s, or up to 140, more so in the 80s, and then the 140s, 150s. You can see a visual of your data. You can do this again on Excel, which we'll get to in Minitab. Now we're going to talk about quartiles, deciles, and percentiles. And what that means is it's taking your data and splitting it into quartiles or quarters, the 4 quarters, or it's splitting it into deciles. Deciles meaning each percentage of 100, so tens. I have first, second, third. So if I ask for the 4th decile, that means the 40th percent. If I ask for there's maybe a trick question. How many, what percentage of the data lies in the 10th decile? What's the 10th decile? If you talk about percentages. What was it? 100%, so it would be, the answer would be all. So that's a trick question I might throw in there, because you'll see 10th decile go, it's 10%, and calculate something and get it wrong. So make sure you read the questions carefully, and know when we talk about deciles, we're talking about 1st through the 10th, and the 10th being 100. And so didn't mean to click on that. To calculate it, you're going to locate where a percentile starts and ends. We're going to use this formula where I have n plus 1, so the number I have plus 1, times p divided by 100, or the percentage. So if I talk about the 25th percentile, then it would be 25% times whatever my n plus 1 is. So let's go through an example. Here I have a list of commissions earned last month at this brokerage firm. I want to draw what we're going to do with this. You have to first put them in order and figure out what the mean, median, and mode, mainly the median and the mode, would be. So first thing, I want to set it up in order from lowest to largest, or smallest to largest. I've done this here. If you go into Excel, type in all this raw data right here, and then click sort smallest to largest, it does it for you. It's very easy. Then I want to figure out what it would be at the 25th percentile and the 75th percentile. So think of it as the 1st quarter and that 3rd quarter. What would the 50th percentile be? And you don't have to give me a number. What's another word for the 50th percentile? Can be the average. Another word. The median. It can be the average. Hopefully it's right in the middle, but it's definitely the median, because if I count all the way in, the median is going to be that middle number. Remember, that doesn't change when I have the person coming in making a 0 or 100. The average doesn't change. The average changes, but the median doesn't. So the median is going to be the 50th percentile. So on the test, if I ask you what's the 50th percentile, and you have already found out what the median is, don't go through this formula trying to calculate it. I've given you the answer. It's just a trick question, another way of answering or asking it. So the first thing I want to do, I want to calculate this at the 25th percentile. There are 15 commissions that we're dealing with. And I look at 15 plus 1, so 16 times 25%. And the answer is 4. That's not the answer, though. If I ask you what is the where's the 25th percentile, the answer is not 4. That means the 4th number. So you'll go back here and you'll count 1, 2, 3, 4. That's where the percentile would end, and the next one would begin at the next one. Same one for the 75th. This is the 12th number, not the number 12. So on the test, I'm going to ask you this, and I will have about 25-30% get it wrong, because they'll say, oh, the answer is 4. On the answer choices, I'll give you the wrong answer as the choice. I will give you the answer of 1721, and I will give you the answer of 4. And sure enough, there will be people who pick 4. Know that I want to know where it starts. What number does it start at on the data set? 12th number is just going to be counting over 12. Now this is an easy question. You're going to get to some that you don't have 16. 16 divided by 4, easy, it's 4. But if I had 22 or 107 pieces of data, then it's going to be hard to, you're not going to come up with an even number where it's the 4th number. I might get the 4.25 number as my answer. So to figure out something like that, to get the 4.25 number, and let me see if I can get this to work. I have 1721 and I have 1758, and that's the 4th number and 5th number. So let's see if this works today. Awesome. Okay. This is going to be on the test because you will have one where it's not going to be 16 and it's easily divided by 4. You will not. I'm just warning you ahead of time. There we go. So let's say, I always get this mixed up which way to go. So let's say that these are the 4th and 5th numbers, and I come up with that my 25th percentile, whatever percentile, is going to be 4.25. That's the 4.25th number. That doesn't mean that's the answer. So that means it's going to be somewhere between here. So what I'll do is I'll take whatever the 4th number is, and I need to figure out what 25% of this is going to be. So I take 1758, 1721, and I find, or 1721, and I figure out what 25% of that is. What's 25% of that? Somebody with a calculator. I should bring candy and throw it when somebody has a calculator. Yes, you can. 9.25? Okay. So that's not my answer either. What I do is I take this plus this. So it would be the 1721 plus the 9.25. And that would be my answer. This is how it will be on the test. It will not be clean cut like this. It will not. Now the numbers won't necessarily be this big, but you will have to figure out percentages in between. So when it asks you that and somebody's like, oh, I don't know, it's the 4th, so it's that one. It will be wrong. Make sure that you figure out what it is in between. Okay, so let's go back here. And then here you can just see how everything is presented in percentiles. If I wanted to look and see how much is, how big my percentiles are. Percentiles are supposed to be that there's an even amount of data in each one of them. So I'm going to show you what that means when we deal with a dot plot. A box plot. Right here, box plot. So for box plots, I'm going to need to figure out what the 25th percentile is and the 75th percentile. Of course, I know the 50th, that's the median, and I know the minimum, and I know the maximum. So this is an easier example because we're not dealing with big numbers. This is an example of what you get on the test. I'm not going to give you, they made $20,000, so figure out this. We have Alexander's Pizza offers delivery within 15 miles. They want to figure out the typical delivery time, and they have this information. The minimum delivery time is 13 minutes, the maximum is 30 minutes, the median, after they've collected all this data, is 18 minutes. And then they figured out what the quartiles are. They've just done that. But you'll have to do this on the test. Again, figuring out your quartiles like normal, but then I want you to show me in a graphic. And what this shows me is that this is the majority of the delivery times between these two numbers, the majority of my time. You can see that these aren't the same size because this is supposed to contain the same amount of data, not necessarily the same size. So what it's saying is that so many observations, the same amount of observations lie between here and here and here and here. It's just showing you where they concentrate. So I'm able to see that the majority of the delivery times are between 13 and 22 minutes. That sometimes we get a 30-minute delivery, and sometimes we're really good and get this 11, or whatever it was. I don't remember if they said 11. They said 13 here. And I think that's just a typo, because it should be 11. So that quartile is going to tell me, again, where 50% of the data lies, between the 25th percentile and the 75th percentile. So on a question on the test, I might ask you, show you this, where does 50% of the data lie? 50% of the deliveries for this pizza service are between what minutes? And you would be able to tell me between 13 minutes and 22 minutes, because 25%, that's 50% of the data. Or I might ask you, is it pretty typical for somebody to get their pizza in 29 minutes? Well, no, that's not very much is out there. It's typical you're going to get it by 22 minutes. So that's what this tells me. You might have a pizza that's delivered in 37 minutes, but that's an outlier. It's an abnormality. It's not normal. This is normal. And here's an example. You can do this on Excel or Minitab. If you go in there, type in your data, and just say, make a box plot, and we'll go through that. Skewness is going to tell me where the data kind of concentrates on the left or the right, or if it's perfectly symmetrical. Again, I'm able to just make predictions about something.